Hello, advanced math students. Today we're going to talk hyperbolas. I have this all set up. Here's a problem here in red. Here's the standard formula for a hyperbola. This is all set up. I got the center pre-graphed. I also have what A and C equal down here, and I'll refer to that when I get to it. So first, we're going to put some purple marks on this for the vertices. So I'm going to show you how to do that. This A right here, A squared is 16. So A would actually equal 4. And what this means is we're going to go out from the center to the right 4 equal spaces as well, or as best as we can do this. Put it right there. And then we're going to go back the other way 4 equal spaces. So that's 1, 2, 3, 4. And we'll put a nice pink dot right here. And let's go ahead and put the coordinates of that on there. So this would be 6, 3, and negative 2, 3. All right, so those are my vertices V. So the distance, and again, this kind of the scale got a little out of whack there, but that's okay. The distance from here all the way through here is called the transverse axis. That's got a special fancy name there. For that right there, it's called the transverse axis. And that is the line that connects the two vertices together. All right, cool. So what A is, this says A is 4, and 4 is the length from the center here to this first vertex. So that distance right there is 4. So I'll say that's A equals 4. Now, the next thing we need to find here is B. B squared equals 9. So B would equal 3. Now, here's how this works. Using another color, we'll go to some purple color here. So we'll go up. We're going to go up from the center. Remember, this is the center here. We're going to go up 3. So 1, 2, 3. We'll put a dot right there. And that is going to be, we're not going to really put the coordinates of this point on here. I'll show you why in a minute. We're going to construct this box here. So we go up 3. We're going to go down 3. So that's 1, 2, 3. So that's going to hit right there. And then from each vertex, I'm going to do the same thing. So I'm going to go up 3, put a dot, down 3, put a dot. I'm going to go to the other side vertex. I'm going to go up 3, put a dot, down 3, and put a dot. Okay. Now, I am now going to construct this hyperbola and find the foci. So what we do here is from this vertex, we went up 3 to get this. So this distance here, that little dotted line right there, is 3 units long. And this is equal to B. There also exists a shiny bright blue line that goes from the center to this point up here. Now this is just theoretical line. This is not part of the hyperbola at all, but it's how you get the focus. That's the whole point of doing this, which we are going to call C. So we got A equals 4, we got B equals 3, and we're going to solve for C, and that's the distance from the center to this purple dot up here, or it would be this purple dot here. And we have, you can see, a classic, I did this on purpose so it would come out nice, a 3, 4, 5 triangle. But if you just want to see that real fast, we would plug this in there, 4 squared. And I'll talk here while I'm doing this. What makes this different is that this thing actually does follow the Pythagorean theorem, unlike ellipses, which we had to kind of reorganize and redo. C would equal 5. So this C right here is 5. Now, when we're getting the foci of this, the way that you have to imagine this is if this was, say, attached and this was the radius and this was a circle spinning, this would come down here and make a dot out here somewhere. And the line from here up to here is equidistant to the line from here out to here. Okay, so this distance here is 5. And if I go out from here, out 5 spaces, I would go 1, 2, 3, 4. I would need to extend that 5. And then this would be my focus F at coordinate, what would that be? 5 out, so it'd be 7, 3. 7, 3. And there would be one on the other side as well. Okay, so this would be symmetrical. But I will show you something. I'm going through a whole lot of geometry here, but there's actually, the equations are made for you. There is a foci equation, just like ellipses. In fact, it's the same thing. It's h plus or minus c comma k. That should look real familiar to you. So you can just say this is my hk. So for the foci, that is 2 plus or minus, what was our c? 5, comma 3. Now remember, usually when you get C, it's going to come out to be something like a radical 41 or whatever. This time I did it to where it comes out a nice number. So these two foci is going to be 2 plus 5, which is 7, comma 3, and 2 minus 5, which is negative 3, comma 3. And so the other foci would be 1, 2, negative 3. There'd be my other foci. So the last thing I'm going to show you is just kind of a cosmetic thing, and it involves these asymptotes. If I do this in like super bright blue, if I connect, and this, forgive me, it might not fit exactly, but if I extend a line all the way through these purple dots through the red, and again, it's not going to hit exactly, bear with me, and through this set of purple dots, the center, and that one, that's a little bit nicer. These two things are called asymptotes. asymptotes. Asymptotes are like mathematical fences that bind, that keep the graph on certain property, right? So if I try to sketch what this actual hyperbola looks like, it's going to come in infinitely close to that light blue line here, graze the vertex, hit it in one spot, and come right out like this and become infinitely close to that. And it'll do the exact same thing on the other side. Infinitely close, hitting that at one point, and back to infinitely close again. So this is a hyperbola that opens sideways, and all the things that go with it, and how to find the foci and graph it. You'll have to go from the graph like this back to the standard form, and you'll have to go from the equation to the graph, finding the foci. That's it. Have a good one and study this one a lot.